It's a quadratic equation. The first question of your maths paper 1 is a quadratic equation. And the question can come in different ways. Right? For your trial paper, it was already factorized. It was already factorized. So you need to know that here, you have got two factors. The first factor is that 2x. The second factor, let me use a different color. The first factor is this 2x, the second factor is 3 minus x. You don't have to remove the brackets because it was already factorized for you. All you have to do is equate each factor to 0. So if you do that for 1.1.1, it's 2x times 3 minus x equal to 0. Right? So you equate each factor. There are two factors here. 2x is a factor, 3 minus x is a factor. You equate each factor to 0. And this question should not take you more than 10 seconds to answer. So this becomes 2x equal to 0 or 3 minus x equal to 0. So your final answers will be x equal to 0 or x equal to 3. Okay, by the way, you can also take this minus x to the right hand side and you get 3 equal to x, which is the same as x equal to 3. I expect you to be aware of that. So be aware that the first question will be on solving a quadratic equation. You have to be a master of solving quadratic equation. Right, so this is the first part. Then the next one, it will also be a quadratic equation. But the second one is slightly more complex. It requires the use of the quadratic formula because the question says rounded off to 2 decimal places. That's a clue that you need to use the quadratic formula, right? And in some cases like this question here, you have to check if the question is in standard form. Your standard form of a quadratic equation, standard form is ax squared plus bx plus c equal to 0. That's the standard form. So you must check if your quadratic equation is in standard form. If it's not, convert it to standard form. Okay? There's no need for you to get scared because you saw this. You should be smiling. Right? So 1.1.2, so we have 5x squared minus 4x equals to 2. It's not in standard form, which means one of the marks will be allocated for making it, or rather converting it to standard form. So we take this 2, okay, the 2 we take it to the right, we end up having 5x squared minus 4x minus 2 equals to 0. So a mark will be allocated for standard form. A mark will be allocated for standard form. In fact, in most cases, even if it's application of quadratic equations, a mark is allocated for the standard form. Don't forget to equate the trinomial to 0. Right? So here, since the question is saying you must round off your answer to 2 decimal places, that's a clue that you need to use the quadratic formula. And your quadratic formula is this. It's x equal to minus b plus or minus the square root of b squared minus 4ac all over 2x. That's your quadratic formula. It is also provided on the information sheet. But I expect you to have it here in your head. Unless if you are not sure, then you can refer to the information sheet. So here, this 5 here, that's a. That minus 4 there, that's the b. This minus 2, that's the c. So, you can write this and say a is equal to 5, b is equal to minus 4, c is equal to minus 2. Right? In most cases, you will allocate the mark for substituting correctly into the quadratic formula. Sometimes the formula itself can also be allocated a mark. So you must make sure that you write down your formula as well. Right? So I'm going to move on to the next page. So I write my formula is x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now my b, it's negative. So when I substitute into this formula here, remember this negative here, this one, that's the negative of the formula. Okay? If the b is negative, then you put the b in brackets. So this will be minus 4, right? Plus or minus the square root of minus 4. You put the b in brackets, it's negative. Minus 4 times a, which is 5, times c, which is negative 2. This is all over 2 times a, which is 5. There is a mark allocated for this step, substituting correctly into the quadratic formula. So this becomes positive 4 plus or minus the square root of 16 minus 4 times 5 plus 20, and that will give you positive 40. So you get positive 40 all over 10. So eventually you get 4 plus or minus the square root of 66 over 10. Can someone convert that for me? With the two answers, two decimal places. Yes? 60. Huh? 56. Right? So,
So like you don't have to do it. You just stop at the substitution and then put in the calculator.
yeah, if you want to do that. What's the answer? 1,15.
Yeah.
And the other one?
0.
3, 5.
0,35. Right? So this should be straightforward. And you should be answering this question whilst you are smiling. Sure. Alright. So you should be answering a question like this whilst you're smiling. Alright? There's no need to be scared at all. Right? Then the next question, we go 1.1.3. Alright? That's a set now. That's a set. So this is 1.1.3 square root of 7 plus 3x plus 2x. Right? It looks scary, but it's not. Right? First thing, isolate the set. Okay? Isolate the set. So square root of 7 plus 3x, that's our set. Right? So we take the 2x to the right, and then you end up having the square root of 7 plus 3x equal to minus 2x. Right? Then the next thing now is to remove the square root sign by squaring both sides. So this becomes 7 plus 3x. You square. You get a mark for this step. Then the minus 2x, you also square it. Like that. One mark for squaring both sides. Right? Then on the left, you'll be left with 7 plus 3x. On the right, you will get 4x squared. Again, this is still part of quadratic equations. So you need to form a quadratic equation in standard form. And you should not be scared because you saw this. So I'm going to take 7 and the 3x to the right. If I do that, I'll get 0 equal to 4x squared minus 3x minus 7. Now, to carry on here, you can use the quadratic formula, which is the easiest way. Okay? Because factorizing this can be a nightmare. Okay? I know from experience, but if you can use the quadratic formula here, you'll never go wrong. That's why you have to be a master of solving quadratic equations by using the quadratic formula. So here, I'm going to factorize, okay? But you can use the quadratic formula. So if I multiply 4 by 7, by minus 7, I'll get minus 28. Please, you don't have to write. If you want, you can write this down. It's just my working out, factorize, right? So, I need two factors of minus 28, such that if I add them, they will give me that negative 3, right? And those two factors, obviously, it will be minus 7 times 4, right? So, I'm going to rewrite this as 4x squared minus 7x. Okay, let me rewrite it the other way. Let me start with 4x. So I'll put positive 4x here minus 7x minus 7. Please don't stress about what I'm doing here. I'm trying to factorize it. You can use the quadratic formula if you have got challenges with factorization. So this will be 0. Then you get 0 equal to 4x times x plus 1. This will give me minus 7x times x, or rather it's minus 7. It will be 7 times x plus 1, like that. So eventually, it means my two factors are x plus 1 times 4x minus 7. Right? So let me move on to the next page. So my two factors are going to be x plus 1 and 4x minus 7. Yes, 4x minus 7. Please, you don't have to do the way that I'm doing. Use the quadratic what? Formula. From here. From here. From here. Use the quadratic formula. Okay? From here. Don't try to say, Mr. Chikona was trying to factorize, I want to do it as well. No. That's not the objective. Use the quadratic formula from there. And the most important thing is being able to get your two x values. And in most cases, for a set like this, you may have to reject one of the two. So you do a check. Right? So once you get there, it means x is going to be equal to minus 1, or x is going to be equal to 7 over 4. Right? If you equate each binomial to 0, you will come to that point. Then you need now to check. You go back to your equation. Let's test x equal to 1. Right? We have got two values, so x equal to minus 1. So I'm going to put minus 1 here, and I'll also put minus 1 there, and see if I'll get 0. So if I put minus 1 here, I'll get 7 minus 3. Right? 7 minus 3. I hope you are following. I'm substituting x equal to minus 1. 3 times minus 1 gives me negative 3. So 7 minus 3 will give me a positive 4. If I substitute here, x equal to minus 1, I'll end up getting minus 2. The square root of 4 is a 2, right? It can be a negative 2 as well. But here we take the positive. 2 minus 2 will give us what? 0. Which means this will be a solution. Let's test that. Right? Then let's put x equal to 7 over 4. If you put 7 over 4 there, right, it will give you, inside the square root, you end up having 7 plus 3 times 7 over 4. And this will give you the square root of 7 plus 21 over 4. If you simplify that, what do you get?
7.
You get an answer as a 7.
No, that's all.
The square root,
7 over 2.
the square root of 7 plus 21 over 4.
7 over 2.
You get 7 over 2. Right? So that's inside the square root. Then you put the 7 over 4 here. Right? So it will be 2 times 7 over 4. Right? This will give you 14 over 4. And you get what? 7 over 2. Is 7 over 2 plus 7 over 2 equal to 0? No. So it means you reject this one here. The checking is a very simple thing to do, because you are just substituting and making a decision whether the solution is valid or not. No need to get scared. So the final answer will be x equal to minus 1. In most cases, in fact, you should get a mark for rejecting that. But that mark will be allocated as part of the solution for x equal to -1. Or it can just be allocated for both values of x, including the rejection. So you have to reject, and you have to show that one of the two values is invalid. You have to show that. All right? And let me carry on. Then the next question is the exponential equation. Exponential equation. Just give me a second. You were supposed to get them. Yes. All right. I'm going to try and make it as easy as possible. So the question is 3 to the power of x plus 2 plus 3 to the power of 2 minus x is equal to 82. The best way of doing this question here is first, you need to break the first term up. Break this up, break that up. Based on the exponents. Do you remember the first law of exponent? Let me write it there. Your first law of exponent says x to the power of m times x to the power of n is equal to x to the power of m plus n. So you have to use that law. Moving from right to left. Okay? So if you follow that, this becomes 3 to the power of x times 3 squared. Are you following what I'm doing? Because it's not as difficult as you think it is. Then this becomes 3 to the power of 2 times 3 to the power of minus x. This is equal to 82. Okay? In my opinion, this is the best way of doing the question, and it won't give you unnecessary challenges. You are just using the first law, moving from the right hand side of the first law towards the left hand side. So it's not that difficult. Then here now, you identify a common factor. You have to identify a common factor. But you also have to work smart because maths requires you to think. So if I take out a common factor here, that will be 3. In this case, it will be 3 to the power of what? Of 2. I take out that common factor. Then I'm going to end up having 3 to the power of x plus 3 to the power of minus x. Like that. And this is equal to 82. Are you following that? Then, if you, I'm sure you can see that 3 squared, this 3 squared here, it's equal to 9. But 81 is not a multiple of what? Of 3 squared. Right? So you may have to manipulate this. Okay? That's 82. You may have to do that. So to do the manipulation, this becomes 3 squared times 3 to the power of x plus 3 to the power of minus x. This is equal to 81 plus 1. The reason why you have to break up this 82 is because the 1 can be written to a base of 3. The 81 can also be written to a base of 3. Okay? So when you do that, you end up getting 3 squared times 3 to the power of x plus 3 to the power of minus x. This is equal to 3 to the power of 4 plus 3 to the power of 0.
So you never taught us a question like this. You never done.
Sometimes in math,
No,
some questions is application. Okay? So this question, and you also have to think. You mustn't say that math is all about memorization all the time. No. Some questions you have to think. Okay? So there's a bit of some problem solving here. Okay? That's why it's probably a level 3 question, this one. Level 3 or 4. So this will be like a higher order question. Right? Then we divide both sides by this 3. When we divide, okay, so if I divide here, I'll divide here.
Not with this cancel out all the bases.
No. That's a big no now. So this becomes 3 to the power of x plus 3 to the power of minus x, and this is equal to. Then here you end up getting, I hope you are aware that we can write the right hand side the 3 to the power of 4 over 3 squared plus 3 to the power of 0 over 3 squared. I'm splitting the numerators under the same denominator here. The denominator is the same. So I can rewrite it as this. If I do that, I'll end up getting 3 to the power of x plus 3 to the power of minus x equal to, using law 1 of exponents, this becomes 3 squared plus, that becomes 3 to the power of minus 2. Alright? Then, now we have to make a deduction and say, okay, since here we have got the same base here, the exponent is positive, the same base there, the exponent is positive. Also here, the base is the same, but the exponent is negative, and here the base is the same, but the exponent is what? Is positive. Right? So the base is the same here, and the exponent is the exponents are also the same. Right? So now you need to be very, very careful. So if you equate this base to that, you end up eventually you get the same value, which is going to be x equal to 2, which is not entirely correct. Right? So my suggestion here is, let's simplify this step. Right? Let's simplify it. So this becomes 3 to the power of x plus. I can write this as 1 over 3 to the power of x. 1. Yeah. Okay, listen. This question here, it was a little bit challenging, I can admit. Right? Then here, we can simplify the right hand side. Now, do you see that there is this 3 to the power of 2 plus that 3 to the power of minus 2? I can write it as 3 to the power of 2, right? Plus 1 to the power of 3 squared. Okay? So eventually I can end up having, now the right hand side I can simplify. But before I do that, let me simplify the left hand side. So here I can rewrite it as 9 plus 1 over 9. It's not in the negative one, so this is positive. It's the 10. Right? Okay. Now, from here, I can you can introduce a new variable if you want. Okay? You can introduce a new variable here. So if I find the LCD, what do you think will be my LCD throughout? The denominator is a 1. The denominator here is a 1. Denominator here is a 1. So what would be the LCD? It will be 9 times 3 to the power of x. Right? So, if that's the case, means I have to multiply this 3 to the power of x by 9. Right? So that becomes 9 times 3 to the power of x plus this 3 to the power of x here to be 9 there to be equal to, I hope you're following what I'm doing. I'm multiplying each term by the LCD. So I can write it, LCD is equal to 9 times 3 to the power. Then on the right hand side, I'm going to have, if I multiply this 9 here, put this 1 by, I have to multiply this 1 by the LCD. It's numerator, so I'll end up getting 9 times 3 to the power of x plus, here I just have to multiply the numerator by 3 to the power of x. So eventually, this will give me 9 times 3 to the power of x plus 9 is equal to, that will give me 81 times 3 to the power of x plus 3 to the power of x. Okay, listen, I found the LCD. Do you understand that part? I found the LCD. Then the next step is to multiply each term by the what? By the LCD. So if I multiply this by the LCD, since the denominator is 1, it means I'll end up getting, wait here, okay, I'm supposed to put a 9 there. Because there's a 3 to the power of x over. You see this 3 to the power of x here, it's part of my LCD. So if I do this, maybe I should have made a small mistake, but let me check that. So 9 times 3 to the power of x times 3 to the power of x over 1. Okay, I'm not getting 9 there. So this is supposed to be, it's supposed to have another 3 to the power of x. Okay, look here. If you find the LCD of an algebraic equation like this, which involves fractions, what do you do next to eliminate the denominators? You multiply each term by the what? By the LCD. So I multiplied this first term here by the LCD, which is 9 times 3 to the power of x. So I should get 9 times 3 to the power of x times 3 to the power of x. Initially, I made a mistake of not putting the 3 to the power of x. So I'm checking now whether what I did there is right or not. Then you also multiply this. So let me use another pen. So if I multiply 9 times 3 to the power of x times 1 over 3 to the power of x, do you see that these two here, they cancel out? And you've left with 9 times 1, which is 9. Are you following that? Then I'm here now. We need to multiply that 9 over 1 by 9 times 3 to the power of x times 9. So get 9 times 9 times 3 to the power of x, which is what I have here. Are you following that? Right? Then I'm here now. So if you multiply 9 times 3 to the power of x times 1 over 9, this 9 and that 9 cancel. You'll be left with what? 3 to the power of x. Is it clear now? Yeah, you can take it.
I'll bring them back.
No, you can add lots of copies of it. You can take it. Right, are you following that? So we end up having this, which I said the first time I made a mistake of not putting the 3 to the power of x. So I'm correcting myself. Are you following now?
Yes.
Okay, so this becomes 9 times 3 to the power of x times 3 to the power of x will give me 3 to the power of 2x. Do you agree with me there? Yes. Plus 9, right, equal to, this will give me, well, I can write that as, now, do you agree with me that this is 110 because the base is the same? So I can write that as 82. It becomes 82 times 3 to the power of x. They are like terms. Look here. There is 3 to the power of x, there is 3 to the power of x. So this one here, we can write it as 1 times 3 to the power of x. Right? Do you agree with me that these two are like terms? That's my question. If you can't see that, then you have problems. They are like terms because the exponential term is the same. The exponential term is the same. So 81 times 3 to the power of x plus 1 times 3 to the power of x will give me 82 times 3 to the power of x. Okay, check this out. Let's say we say, okay, let 3 to the power of x be k. Okay? Let 3 to the power of x be k. Do you agree with me that I can write this as h1k plus k? What is h1k plus k? 82k. That's why I'm writing that. Alright. Now, quadratic equation is coming. So this becomes 9 times 3 to the power of 2x. I'll take that 82 times 3 to the power of x to the left. So we get 82 times 3 to the power of x plus 9 equal to 0. Right? Then I can rewrite this using 3 to the power of x. You agree with me? And write that as 9 times 3 to the power of x all squared minus 82 times 3 to the power of x plus 9 equal to 0. Right? Then I will introduce the substitution, the k method. So let k equal to 3 to the power of x. So this becomes 9k squared minus 82k plus 9 equals to 0. Right? Then I can factorize this because there is a 9 here, there is a 9 there. So 9 times 9 will give me 81. Which two factors of 81 will give me minus 82? It's going to be minus 81 and minus 1. So this becomes 9k squared minus 81k, right? Minus k plus 9 equal to 0. Okay, it looks scary, but it's not. Then this becomes 9k times k minus 9, and that one becomes minus k minus 9 equal to 0. Okay, I'm feeling happy now because I'm getting there. Yeah.
When you explain the 82, that the value of 82 minus 3 or
Okay. 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 The first thing I said, if you want to avoid, I think this should be one of the reasons why most learners could not do the question. Right? These two are like terms because of this. So you can say, okay, if I want to explain it from how I get 82, I can say, let 3 to the power of x be k. What is 81 times k? 81k. Then where there's 3 to the power of x, you put k there. So you end up having 81k plus k, which is 82. But the k is equal to 3 to the power of x. So you end up coming to this.
so how come we didn't say let x equal k?
Huh? Okay, I eventually decided to do it here, but we could do it from here. So that when there's 3 to the power of x, you put k, here you put k. K times k gives you what? K squared. Are you following that? Huh? Okay. So eventually, this will give us 9k minus 1 times k minus 9 equals 0. Right? So if I go to the next page now, I'm still solving for k, but remember, the objective is to solve for what? For x. So this is 9k minus 1, that's k minus 9. So that will give me 9k minus 1 equals to 0, or k minus 9 equals to 0. So this will give me k equal to 1 over 9, and the other will give me k equal to 9. Right? But when k is equal to 1 over 9, remember we say k is equal to 3 to the power of x. So I'll put 1 over 9 there, right? And then convert that 9 to a base of 3. So you get 1 over 3 squared is equal to 3 to the power of x, which is the same as 3 to the power of minus 2 equal to 3 to the power of x. So you get x equal to negative 2. That's the first value. The second one, since k is equal to Are you following it? Please, can you do me a favor? You need to concentrate. You really need to concentrate. So when k is 1 over 9, x is minus 2. Then, when k is equal to 9, so that becomes 9 is equal to 3 to the power of x. This gives you 3 squared equal to 3 to the power of x. Therefore, x is equal to 2. Now, some learners who try to do the question, they got one answer, which was x equal to positive 2, but they didn't have the x equal to negative 2. And this question was a problem.
When we're doing it on the other side, when we got this, what is the difference between
But you have to show all the working on with the basic.
with the bracket?
Okay. You have to use the quadratic equation. So the quadratic formula, it's fine. You use the quadratic formula. Remember, I need to emphasize this, boys and girls. When you get here, see here, please, don't say that Mr. Chiponda did not use the quadratic formula, so I want to factorize as he did. No. You have another option, which is the easiest option. Which is the what? The quadratic formula. Don't get here and start wasting time trying to figure out how are you going to factorize this. Use the quadratic formula. And you never go wrong. You will come to this. You will come to these two solutions. So don't try to factorize. Write down your quadratic formula, substitute into it. So, right, let me talk about the simultaneous now. Before, like the simultaneous. Before I move on to the simultaneous, or rather the inequality, you need to know that this question is a level 3 or level 4 because it involves some complex procedures. Okay. Right. Then this question here, for your own information, it was an inequality in disguise. Because the questions were saying, for which values of x will the square root of x squared minus 5x plus 4 be real? So, if that trinomial is going to be real, it's supposed to be greater than what? 0. So this was an inequality in disguise. Okay? So you have to know how to solve inequalities. So all you have to do was to say x squared minus 5x plus 4 must be greater than 0. Then you factorize this to be x minus 4 times x minus what? That will be minus 1. Greater than what? 0. Okay? So if we check this, it means your critical values, CB, you equate those binomials to 0, so you get x equal to 4 or x equal to what? To 1. Those are your critical values. Then you use the number line. Let me warn you, on the 5th of November, whether you like it or not, you have to solve a quadratic inequality. So you cannot come on the 5th without knowing how to do it. So let's use the number line. If I draw my number line, if I put 1 here, put 4 there, okay, then draw that vertical line, the number 1 there. Be aware that to the right of 4, that x is greater than 4. Between 1 and 4, that 1 is less than x is less than 4. To the left of 1, that x is less than 1. Then, right before I came up on, you all understand what I just did there?
Yes.
Huh?
Yes.
Then the next thing is trial and error for each interval. Normally, I prefer to start with this one. Choose the value which is greater than 4, like a 5. Put the 5 here. 5 minus 4 will give me a 1. Right? Let me use a different color just to make it look nice. 5 minus 4 will give me 1. 5 minus 1 will give me a 4. 1 times 4 gives me a 4. Is 4 greater than 0? Yes, which means this is the solution. Are you following what I'm doing? You can't solve a quadratic inequality like how you solve a quadratic equation. You have to use trial and error. Some calculators, they can solve quadratic inequalities. Is there anyone who's got a calculator like that here? There's a silver calculator which can solve an inequality like this. Yours can do it. That's an advantage. Okay, right. Right. Let's get on. Then let's choose a value between 1 and 4. Right? Like say a 3. Put 3 here. You get 3 minus 4, which gives you minus 1. 3 minus 1 will give you a 2. Minus 1 times 2 gives me negative 2. Is negative 2 greater than 0? No, it is not a solution. Are you following them? Are you following? Right? Then we are now the third interval. Choose the value that's less than 1. I'm going to choose 0. Right? Put 0 here. 0 minus 4 will give you minus 4. Put 0 here. 0 minus 1 gives you minus 1. Minus 4 times minus 1 will give you positive 4. Is positive 4 greater than 0? The answer is a big yes. So this is a solution. Which means, in the end, you say, therefore, x is less than 1 or x is greater than 4. And then you are done. It's not difficult. Just imagine, before you write a paper, you do maybe 10 or more questions like of this type. I can assure you that on the day when you see it, you'll be smiling. Okay. Right, then the simultaneous equation, whether they like it or not, this is also another type of question that you have to be ready for. Right? So we need to solve these two simultaneous. So we're given xy equal to 12 and x minus 4 equal to y. Since y is already the subject here, there is no need. If I call this one here equation 1, that one will be equation 2. In equation 2, y is the subject. So you don't have to stress trying to make x the subject. So first thing that you have to do is substitute this x minus 4 here. Put it there because it's equal to y. So if you do that, you get x times x minus 4 equal to 12. It was so easy. This one here, it was so easy. Then you get x squared minus 4x equal to 12. Standard form of the quadratic equation. X squared minus 4x minus 12 equal to 0. Then you factorize this. X minus 6, or you can use the quadratic formula if you feel that you can factorize, and then x plus 2. So your two values of x will be x equal to 6 or x equal to negative 2. Now, these are very important steps. This substitution here, that's very important. The standard form, okay, the factorization, or if you use the quadratic formula, you're substituting into the quadratic formula and the answers both x values. That's very important. Right? Then to get the y values now, so let me use that. Right? To get the y values, so we say when x is equal to 6, what is y? Y will be equal to x minus 4, which in this case will be 6 minus 4 and you get a 2. Then, when x is equal to minus 2, y will be equal to minus 2 minus 4, and that will give you negative 6. And then you have that. And this question, I can tell you, you could do it within a minute because it was not very challenging. Sometimes they can bring a question like this which requires knowledge of exponential equations. So you have to apply your knowledge of exponential equations. Okay, but I feel like this one was a very easy question. Okay. Right, so that's it there. Up to your trial there. Has anybody else got any questions so far?